All right, hello. Here are some derivative questions from class from yesterday. Remember first and foremost that we're going to use the definition of the derivative to find the equation of the derivative, which I'll just put over here, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, that is your definition of a derivative. First and foremost, let me remind you that when you're finding a derivative, you're finding the equation to then find the slope at any given point on a curve, okay? And so the idea is when you find the slope between 2 points, that's what h is. It's the distance between those 2 points. So like we did yesterday in class, we're looking at, we want the distance between those 2 points to be almost non-existent. So realistically, it's almost like we're finding the slope specifically at 1 point. Okay? And that's what the equation of the derivative is going to give us, is that access so that we can then find the slope at any point on a curve. Okay? So I'm just going to go over a couple of these problems together here real quickly to give you a heads up. One of the questions that was asked right away was problem number 5 in class today. And so remember when we're doing this, you need, this is kind of the f of x plus h is kind of like your y2, and then f of x is like your y1. So you're taking one equation minus the other. So we have our f of x equation. We need our f of x plus h. So if we do that, f of x plus h for this problem is going to be 2 times x plus h cubed. Okay. Now we've got our f of x and our f of x plus h. So now we can start finding the limit as h approaches 0. F of x plus h is this part that we just said, minus f of x, okay, 2x cubed, all over h. Now, one quick heads up, it doesn't happen on this problem, but remember when you're subtracting f of x, in this case we only have the 2x cubed, but if you have a problem like this where you have more than one term, remember, put that in parentheses so that when you subtract that quantity, you remember to distribute the negative to both of those terms, okay? So don't forget that part of it. Most of the problem we're gonna have here is if we go through, oh, this should be cubed, not squared, is we're gonna be taking that x plus h and cubing it, okay? Which is gonna take a while. I'm just gonna do it over here in this space just because we have enough room. So if I take x plus h times x plus h, okay, if we square it, that gives me x squared plus 2xh plus h squared. Okay, there's x plus h squared. We now, in order to get the cubed, I still need to multiply it by another x plus h, meaning I'm going to take the x and distribute that to each one of those terms, and then I'm going to take the h and do the same thing. And then we'll combine like terms from there. So if we do that, x times x squared gives us x cubed, x times 2xh gives us 2x squared h, and x times h squared is exactly that, xh squared. So that's what we get when we distribute the x. Now I'm going to take the h and distribute. So we get plus x squared h plus 2xh squared and plus an h cubed. And now if we clean up any like terms, we've got x cubed, there's no other x cubes. We've got 2x squared h's, and then here's another one for a total of 3x squared h. We've got an xh squared and a 2xh squared for a total of 3xh squared. And then we still have plus h cubed, okay? So that is x plus h cubed. Quick heads up, by the way, when you look at future problems, notice in number 7 we have a cube. Well, again, don't go back and redo all of this work. Just use the answer that you got from number 5. When you get to number 8 and you're doing x to the 4th, you're going to have to do an x plus h to the 4th. Well, just take this answer and multiply it by another x plus h. Don't try to save yourself some time. You don't have to go back and do the whole problem all over again, okay? So use that answer as you're working on 7 and 8, just as a heads up. Now, when we finish up, or as we continue here on number 5, that's what x plus h cubed is. We still need to multiply everything by 2. So what we're going to end up with is we're going to get 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed. Okay, and that's all over h still. And so now if we start cleaning this up, if we start, oh, almost forgot one thing. Before we start cleaning it up, don't forget, that's this part of the equation. We still have that minus 2x cubed at the end. That's still there. Now we can start cleaning stuff up. 2x cubed and negative 2x cubed are going to cancel out. Let me get rid of this stuff over here so we've got some room. And now, if you notice, you've got a 6x squared h, 6xh squared, 2h cubed. Every one of those three terms has an h in it, so I can pull out your greatest common factor. So if I take an h out of that, we get 6x squared plus 6xh then plus 2h squared. Still all over h, and if you notice now, the h that's on the top that I pulled out can cancel with the h that's on the bottom. Those cancel out. And remember, we're trying to find the limit as h approaches 0. Well, once those factors cancel, now h actually can approach 0. We don't have to worry about having 0 over 0. We don't get that indeterminate form anymore. So now with what's left, I can plug in 0 for h and see what I get for an answer. And if you do that, this term's going to go away because it's going to equal 0. That term's going to go away because it'll equal 0. And there's your answer to the problem. 6x squared is the derivative of 2x cubed. Okay? And now remember, that's the derivative. That's the equation of the derivative. Remember, now I can use that equation and plug in any value of x that I want to find the slope of that point, or to find the slope of the curve at that specific point of your original cubic function. Okay? I can plug in x equals 1, find the slope. I can plug in x equals 5, find the slope at x equals 5. That's what the derivative is doing. Okay? So there's your first option right there on number 5. Like I said, 7 and 8 are a little bit more of an extension of what you're doing, but very similar problems. Okay? One other question that was asked today, let me kind of work our way through this one. Let me get rid of all this stuff, was problem number 6 was also asked as to go over as a problem. And so if you take a look at problem 6, okay, there's your f of x. Our f of x plus h is 1 over, take the x out, put x plus h in its place. So there's your y1 and your y2 basically. This is your y2, this is your y1, your original equation. Okay, so again, we're going to find the limit as h approaches 0, okay, as the distance between those two, it basically goes to 0. 1 over x plus h minus 1 over x all over h. Okay? And once again, if we went through, I can't plug in 0 right now to find the limit, so we have to kind of manipulate this a little bit. And this should look somewhat familiar. This is very similar to the problems that you saw in the last chapter with dealing with limits. This is one of those ones where we need to clear the fractions, and then we can go from there. So I'm going to multiply this entire numerator by the common denominator, which is x times the other factor, x plus h. I'm going to do the same thing down here in the denominator, x times x plus h. Okay? So when we do that, if I take this and I distribute times the first fraction, the x plus h's will cancel out, leaving you with the x, the first factor, times the numerator. So we're going to get x. Then we multiply that, we distribute to this fraction. This time the x's are going to cancel out, leaving you with the x plus h times the numerator again. Don't forget that negative goes with the 1, and then we need to distribute that into that x plus h. So we're going to get a minus x and a minus h. There's your numerator. And then just leave your denominator in factored form again. We're going to get h times x plus h. There's your 3 factors. And now if we start cleaning things up, x minus x, those cancel out. Notice we end up with an h on the top. We have h as a factor on the bottom, so those can cancel. And ultimately that simplifies to negative 1 over x times x plus h. But again, oops, because those h's canceled, now I can actually find the limit as h goes to 0. I can plug that in. If I do plug that in right here, this should be x plus h, not times h. If I do plug that in, x plus 0 is x times the x that's already there, gives me a final answer of negative 1 over x squared. There's your equation of your derivative for 1 over x. Okay? And once again, if you wanted to, now you can start plugging in different values of x to find the slope at those specific values. Okay? So hopefully that helps you a little bit as you work your way through this assignment. Some different questions, like I said. If you need more help than this, by all means, please come on in, contact me, and we'll bring you in during ELT, and I'll sit down and we'll go over this together. Okay?